All right, chapter 7. Let's recap. Chapter 7, 7a, you already saw. 7a was analyses of power functions, so x to the power of 1 on n. Yeah, so you had an exploration of it. The whole point was not to memorize it, but to learn to analyze it. 7b, which is today's lesson, 7b is going to be just revision of composite plus inverses, which you already did. So remember, 1e was composite function. If you still forgotten the properties, there's only 2 key things that you had to learn from that and then how to apply. So that's from 1e. 1f was inverse functions. So if you had to fill this in, remember g of f means f is subbed into g. Range of s is subset of domain of g. If that is true, so if condition 1 is true, then the domain of g of f, which is the domain of the composite function, will equal to the domain of what you're putting in. So if you're putting f into the function, the domain of f will actually equal to the domain of g of f. So condition 1 has to be held first before condition 2 is met. Exercise 1f, one of the key things is inverse functions. We know that domain of f is equal to the range of the inverse, and then the range of f is the domain of the inverse, but also there's one more thing. What's the other skill the examiners will test you? Which we also tested you on the SAC. Inverse functions. You remember? What was that? Yep, which is this bit. So that's one of the key ones. There's one more key thing. Keyword is the inverse functions. Because they could have said inverse relation. They're saying inverse function. 1-to-1. Inverse functions only exist if the function is a 1-to-1. That was one of the key concepts, which generally that's how they tested. That's what we did when we talked about finding the value of a, and most of you looked at it and found the turning point, said negative 0.68 or something like that. But we said a was an integer, had to be negative 1. The point was we're testing, did you know it had to be a 1-to-1 function? Okay. And then obviously domain and f, domain range, you had to prove that bit. So those of you are pretty much core for 1e, 1f. That's it. But on top of that, there was this little bit that's normally added into your textbook, and they're often tested in the exam just for 1 mark or so. Strictly increasing and strictly decreasing. By definition, this is the definition. All it means is when you say strictly increasing, it means that within that interval, it is always growing. It's not like going down, there's no flats. Okay, that's what it just basically means. Is it always growing within that interval? That's what strictly increasing means. Where increasing, sometimes the function go up, down, but then it's still, overall, it's still increasing. Get me? So overall, the trend is that's an increasing function. But is that strictly increasing? No. Strictly increasing is this bit. This bit is strictly increasing, whereas that bit is now decreasing. That's strictly increasing. Get me? So by definition, they're trying to say if A is bigger than B, so on the x-axis, if you choose a number that A is bigger than B, so if A is bigger than B, then I expect that the y value for A should be also bigger than the y value for B, if it's all increasing. That's why they're saying here f of A is greater than f of B. Okay? Why is this important? It's because if you have a graph that has a turning point, and this is where the confusing part where a lot of students get confused by. See, from this point, let's call that A, and let's call this B. We know that from this point to this point, that's always increasing. Okay? That's definitely increasing there. The question is, when they ask you which interval is it increasing, do you include A and B? Do you include that endpoint or not? That's the only difference. Okay? And a lot of students will not include that endpoint. You are meant to include it because by definition, the next value is still larger than this value. And then the next value is still larger than this value. And then same thing at the very top, that value is technically bigger than the previous value. So it still fits the definition. So yes, you do include it. Why do students not include it? I think it's because of the next line that confuses the students. So students already know, strictly increasing, there will have to be a one-to-one. Okay, so that's cool. But it's the next bit. This is a tool to test. Technically, yes, within the interval, if it is strictly increasing, then the gradient should be increasing. The rate is increasing. So they say here, derivative is greater than 0. And this is where students get confused. So when students say, oh, yeah, gradient has to be greater than 0, then they don't include A and B. Why? Because they think, oh, yeah, that's the minimum, that's the maximum. Minimum and maximum, that's the derivative, is 0. And because we just said derivative is greater than 0, yes, and that's what I'm trying to say. This is the definition. This is a tool to test. Within that interval, it's true. But it doesn't mean this test is broken if it equals to 0. That's why you got to understand the theory, what strictly increasing actually means. This is a test that, yes, strictly increasing also means the rate has to increase. Okay? And then same thing for if it's strictly decreasing, then the derivative is less than 0. Okay, so I find that students who memorize just that bit and they just find the derivative and say, yep, it's gradient's positive, therefore it's strictly increasing. Not technically true. Yes, it is sub part of it. This is the definition. If you wanted to prove it, this is how you prove it. Okay, this one is just one of those tests that it should also fit along. Should end up being a one-to-one, and yes, should be increasing as well. Okay? All right, so I just wanted to clarify that if you're in the exam, really the only thing they're testing there is do you include that endpoint or do you not? And students who confuse between increasing only versus strictly increasing will either include or not include. Okay? So just make sure to include for your endpoints. Other than that, like I said, you can do exercise 7B to kind of summarize 1E, 1F, or you can go back to 1E, 1F. These questions here aren't easy, so I've tried to guide you, and I'm going to go through with only maybe the next bit, so I'm going to give you some time to do it if you want to. This is only for special kids and those who are feeling pretty comfortable 1E and 1F and want to have a go. This is one of the VCAT questions, VCAT 2016. Question 4D. I'm just going to rub off my notes here so that you don't see it. See if you can figure out. There's probably many other ways to prove it, but I try to guide you with my way of doing it. Here we go. So they're saying, let g be the function where it's negative k to infinity, where g of x is this function, and k is greater than 1. Okay? Show that if x2 is greater than x1, okay, so the number for x value is bigger than the previous one, implies that g of x2 is also bigger than g of x1. So essentially they're saying strictly increasing. Okay, so it's a strictly increasing question. How do you show that this is true? Like I said, it's probably more of a special kind of approach, but the rest of you, for those who are just doing the methods component, I'd rather you go back and make sure you understand the theories of 1E, 1F. This one's just nice if your algebra is strong and your theory is strong. Have a go. If you did want some guidance, my notes already kind of guide you some hints on how I would approach it. See if you can unravel it. And if you can't in the next 10, 15 minutes, I will then go through the answers for that one. If you want to try again, the next page has another one that I also did. But at the moment, I'm just going to leave it there for you to try. But that's all for 7B. 7C, 7D, sums and products of functions, which you already did in 1G. And then finally, family of curves, 7E. Okay, so out of all the chapters, I'd probably say 7E is the most important one. So hence, this week is just revision. Take your time to do chapter 6. I'm just moving along 7B, and then by Friday, I'll do C, D, and E together, because I won't really be doing C and D. I'll just be focusing on E. Okay? All right, team, I'm going to pause there, and then we'll have a look in 10 to 15 minutes, see if you wanted to fill in the solutions for this next bit. All right, let's have a look at what I did here. So some of the key things to note, k is greater than 1 and negative k to infinity. Those are our starting points. So the domain is from negative k to infinity. I drew a number line and I colored in red. So x is bigger than x1, but then negative k to infinity will start from here onwards. They said that k is bigger than 1. So k, let's say 1 is here, then k has to be bigger. Whatever that value is, k is currently bigger than 1 there. Okay? So What this tells me is that x2 is greater than x1, and x1 must be then greater than the smallest value, which is negative k. If I followed through and just rearranged it by timesing them all by negatives, so it just means that I swap negative k times negative becomes positive k. x1 times negative 1 now becomes reflected, so it becomes x1. So the greatest value, x2, now becomes the smallest value, negative x2. So I got a number line to compare with. Okay. Now that I've got the number line, I can say, all right, so they're wanting us to show that if x2 is greater than x1, it should imply that g of x2 is greater than g of x1. If I rearrange that minus g of x1 on both sides, then I will get g of x2 minus g of x1 should be greater than 0. Well, let's prove that this is going to be positive to begin with, because that's what we're trying to say. So let's prove that. G of x2, sub in x2 into the equation, and then sub x1 into the equation. This is what you get. So I printed it out for you. So from this step, how do you add fractions together? Denominators need to be the same. So I just times this right denominator by the left and the left by the right, or the cross method, whatever you want. And this is the only part you guys had to do. Put them together, expand the numerator, and I've done the expansion for you. So just in case you couldn't do that correctly, I've done the expansion. And what's nice is the k's, kx1, 2, take away kx1, 2 cancels out. K minus k cancels out. And then this next step, there's a bit of algebra happening. K squared x2 minus k squared x1. They both have a common factor of k squared. So I took out k squared as a common factor. That means you've got x2 minus x1. What's left over? Positive x1 minus x2. And then from here, the little trick is that's x2 minus x1. If I can make that x1 a negative and that one a positive, then they have a common factor. So what I did was I took out negative as a common factor, and that changes it to x2 minus x1, which is what this line is saying. Now that these two are the same, I can take them out as a common factor, and you're left with k squared minus 1. Okay, so I replace that now in the numerator. Let's replace that numerator. And then hopefully from here, you guys can then use the number line to picture what's actually happening. So you can see the numerator is now k squared minus 1. Well, since k is greater than 1, every time you square some number greater than 1, you minus 1, it has to be positive. x2 minus x1, we already know x2 is bigger than x1, so it has to be positive. x2 plus k, again on the number line, x2 is over here. If you plus k and k is greater than 1, well, it has to be more positive. And then same thing, x1 plus k is more positive. So since both numerator and denominator are positive, positive divided by a positive must be positive. So g of x2 minus g of x1 is a positive value, which proves that it is greater than 0. And on the right side was me trying to do that description as I'm describing to you all. Okay. But there you go. That was my way of doing it. I'm not sure what the answer is on how VCA would have done it, but that's how I did it. They probably had a more succinct way. That took me a while to write out and do. I think it was an exam 2 as well, so not sure. Yeah. Anyways, thought that was a cool one. It might be similar to chapter 7. They might have a few of those in there. But at the end of the day, that's more algebra and a lot of manipulation. The whole point was to understand strictly increasing just means if x2 is bigger than x1, then the y value will be greater as well. Okay? So here, just the top bit is your key theory. The rest is practice. Okay? All right, team, I'm going to stop the video there, and that is your time. Remember, next week we're starting calculus.